Congratulations, you made it to the last section of the quiz review, section 9, writing equations of a best fit line. I want you to understand that this is one of the harder concepts in this unit, so if you're not getting it, that's okay, but it's not too bad. This is an example of a scatter plot. I hope you know a best fit line is a line that's kind of like an average, a line that goes through most of our points. Now, this is not a good best fit line because number one, it's curvy, and number two, you're going to notice that it does not accurately go through my points. If you look at it in terms of an average, I want an equal number of points to be above and below the line. Right now I have 3 points above the line. I'm going through 1, maybe 2 points right here. Then I have 1, 2, 3, 4, 5, 6 above, 3 on bottom. That's not good. This line needs to move up, and it probably even needs to be rotated a little bit so that more accurately goes through this. When it comes down to it, I'm going to give you a clear protractor or ruler that helps you to see this, that you can kind of move around. And since I have the gift of technology with me right now, I'm going to just draw a line and kind of manipulate it myself. So here's my line. Let's see how I did here. I went through 1, 2, 3, 4, 5 points, maybe 6. I got 2 below and 3 above. Now, here's the issue with this. If I move it up any higher, I'm now immediately going to have more points below than I am above. So I kind of like where it's at, and more than that, although I only have 2 points below the line, these 2 points are much farther from the line than these 3 points are. So I'm willing to bet that if I average the distance, that I would still be, I don't know, at an equal amount between these two lines. Okay. And if that is the case, I've got a good best fit line. You don't necessarily have to have an equal amount of points, but if not, they need to be, add up to have, about an equal distance. Anyways, this line right here, assuming you've drawn it well, it's pretty easy to give the equation. You use slope-intercept form, which by now hopefully you know is y equals mx plus b. Always begin with b, the y-intercept. In that case, it is where the line crosses the y-axis, which is right here. In that case, that's this point, 100. So y is going to be equal to something x plus 100. I don't know what that something x is yet. I'm going to go ahead and write x, though. And that something will have to be my slope. Now, to find the slope, you're going to need to find 2 ordered pairs. One ordered pair that you can always bank on is your y-intercept. 0, 100, or excuse me, 10, 100 is the initial point. It's the starting point. Another possibility would be this guy right here, 16, 300. Now I realize that this point is not that yellow point over there. In fact, I had to draw this point. You don't want to use, these random points on the scatter plot as your 2 points. For example, if I use these 2 points, I have no idea what the rise and the run is between these 2 points. It's impossible to tell because they're not whole numbers. Instead of using the actual points, use your own points that are on the line. Now that I have those 2 points, I can count the rise. It appears to be 2 over 3, but watch yourself. Look at your scales. In going up 2, I actually rose by a whopping 200. And in running 3, I actually went from 10 to 16, which is over 6. 200 divided by 6, you might have to do some simplifying. You could half those. You could end up getting, 100 over 3. And then from there, you could say, well, this is about 33.3, or you could leave it as 100 over 3. Either way, this is the slope. You just put it in there, and now you've got yourself a good old linear equation. Hopefully that helps you out. If there's any confusion on this, please let me know, and I'll be happy to help you further. Thanks, guys. Good luck studying.